right. Well, so this is for anybody watching on the live stream. I'll explain what this is. This is a pretty typical design review of core language functions for Wolfram Language, inventing what we are going to build in the future. And you are jumping into the middle of a fairly elaborately abstract discussion of a function called curry. Okay, so we've already talked a bunch about curry, but let's go ahead and start looking at what we were going to look at. Okay, so did you, Jose, why am I getting that? Okay, did you make the changes that we discussed yesterday or not?
Some of them. So I've changed the wording a bit of the definition box, and yes, but there are still some comments there.
Okay, so can I run this somewhere?
The X-kernel has curry, yes.
Okay.
Most of
and
the
we've also got
definition.
notes from yesterday, right?
Sorry, say that again, please.
We've also got some notes from a while ago.
Yes, you made some notes yesterday.
Let's see. What were you looking at?
You have curry 04 there.
Okay.
In your list of recent files.
Okay, was that the one that was relevant?
That's the one we were writing yesterday.
Okay. Mm-hmm. All right. Well, so
okay.
Let's look at the case that we still have to discuss.
Mm-hmm.
So let's go through the basics here. So let's look at some use cases. So curry of f. So what we've agreed, curry of f of y of x is f of x, y. So what's a real use case for this? It might be something like curry of partition of 4, of range of 10. Is that right?
Yes.
So
and another example I'm interested in is order. For example, to reverse the argument order in order.
So how does that work?
It would be curry of order and then say 1,2. And yeah. And in this case, yeah, for example.
Okay. What does that do?
Mm-hmm. So this implements reverse order.
Why?
Because order of 1,2 would give 1, while here the arguments are being passed to order reversed.
Oh, I see. Okay, I understand. I see. That's a little weird. But so effectively, what in this case, what it's looking like is a composite function of some kind, where where it's turning this sequence of subvalues into a composite function. Okay, so let's take a look at the cases that we had not understood.
I have a question. So, how much evaluation happens at the various stages? Like if you just make curry of partition of 4, does it stay unevaluated or does it evaluate?
It canonicalizes a bit.
I see. So say,
so that's giving the argument order sequence.
I see. I was wondering about functions that take multiple number of arguments, like sum at each various ones, or some that like, does it evaluate if it has enough, or does it wait until it has a certain number?
Okay, so let's take sum as an example. So let's do sum as an example. So this will be an interesting case. So to make a summation operator like that. Okay, so that's just going to sit there. So let's take a look and see whether that applied to 1 over n squared, for example, does the right thing. Amazing. That's kind of cool. We don't want some special output form for this curried thing here, do we?
Perhaps we do. It would be nice to have even an input form, perhaps. I don't know.
Well, the other possibility is during canonicalization, it's not obvious we want to give that 2-1 there. We might want to leave it as curry of sum.
Yeah, that can be done.
I think we do. I don't think we want to give the 2-1 because I think this is kind of a nice case. I mean, another question which we should raise is whether curry is the right name. I mean, curry is the technical name, but you know what this is really making is some kind of composite operator of some sort. Isn't that right? I mean, it's basically taking what is it doing? It's creating a function. Can you describe it in some other way?
Yeah, I was thinking of whether this should have function somewhere or it's some sort of transformation of the function. And there is also the question of whether this is carrying or uncarrying, because you can read it in both ways.
Well, by the time we call the function uncurry, all is lost. But let's say it was something like
could be curry out instead of carry out.
That is almost a pun. What do you mean by curry out? What do you mean?
The carry
like
out
take out
this operation.
Indian restaurant or something? What's that?
Carry out this operation, but not carrying out, currying out.
Is that more than a pun?
10% more.
Okay, fine. Okay, but so the notion of operator form. Let's see. You know, what you're creating, it's kind of like, well, I wonder what just the world at large, whether it has any synonyms for curry. I mean, what I called this, a thing a bit like this in SMP, but that was a very 38 years ago or something, was tearing, T-E-I-R. Probably not very useful. So in other words, is the function in multiple, I mean, the concept there was this concept of multiple tiers or flattened out. I mean, this is some kind of, I mean, I don't really like this because that would be more like an output form, but it's kind of like
something like unarize, because it makes everything uni argument.
Well, it undoes the unarization.
Kinda.
I mean, it's what it is it's a wrapper here that is what this is it's representing the such and such form of F. I mean, this wrapper around F is more like, you know, it's not. Yeah, I see what you're saying. So F has been unarized in some sense.
Right. In the sequence F prime, F2 prime.
What do you mean? So I mean, it's like the unary form of F. Well,
maybe what happens in, so far we had mostly examples with 2 arguments. What happens with 4 arguments? Does it fully curry 4 times?
Yes, it's fully currified. I mean, it's fully curried. So, well, actually, that's not quite correct. I mean, if you do something like this, it'll do, what is that doing? No,
I meant actually of A, of B, of C, of D.
Yeah, right, comma 4, F, comma 4.
Yeah, I understand. If I do that, then I can do something like this.
Yeah.
Then it pulls them all together.
Yes. The brackets, the positions of the brackets does not matter.
It's kind of like a bracket flattening, but what would this be in the world of combinators? Anybody know? I mean, this is kind of a, let's see. I mean, this is in I wonder whether there's any useful name for it in yeah, I mean, there's words like partial application. Partial, yes. Partial.
But this precisely this waits until it has all arguments it wants.
Right.
So it doesn't do any partial evaluation.
What about things like chained? Because it's making. Well, okay. Let's keep going with the semantics. I'm not sure what this in terms of. Let's talk some more about the semantics.
So sorry, I see that you are adding ed at the end. Could this be carried instead of carry?
I think it would be better to call it curried. I think it would be better. I don't think I still think it's obscure as hell.
But this operation is typically known as carrying, right? That's more or less standard.
Yeah, but on the other hand, the operation here, I think it's reasonable to say curry of F gives a curried form. I think that's the right thing. That's the active thing that we want to give.
You mean curry would return carried?
No. I'm arguing against curried actually. Well, okay. Let's keep going with the semantics, can we please?
Yeah. So something that we explored yesterday is the notation with arrow, so that there is a number goes to arrow. Sorry, a number goes to list, or list goes to number, or list goes to list. And I have been exploring that a bit, and it adds some flexibility, but the question there becomes.
Somebody has pointed out on our Twitch stream, somebody has pointed out that doesn't it seem weird that this curry turns into that? And in some sense it is weird, but it is the useful form. So in other words, to get it the other way around would be f of 2, 1, right? No, f of 1, 2.
1, 2.
X, y.
Exactly.
But it is kind of weird that the default case, the default case is not useful. This case is much more useful than this case. Exactly. But it might inform the name to understand that it isn't quite the right thing.
Yeah, the vast majority of the cases we carry automatically are carrying the second argument.
Yes, right. But again, that might inform the name of the thing. But in any case, let's
May I have another question?
Yeah.
Like, assume I want to query plot, say, with respect to the plot range, but I also want to supply options later. Can I do this?
Not easily in this form.
We are preparing
a way to do options, right? So we can do that. Oh my gosh, what is that? Oh no, that's not what I want to do, is it? I want to do this of that.
Yeah, so the way we were preparing to do this is plot of list. In this case, it would be 2, 1, and in the list we put the options. It's not implemented yet, but that's the way we were preparing. Or perhaps I have implemented it. I don't remember. Can you try after plot, do comma, list 2, 1, comma, plot range goes to all.
Sorry, say that again. So here, plot,
yes.
What?
Yes, there, comma, 2, 1, and in the list, inside the list, we say plot range goes to all. Because somehow this was saying put the argument 2, the argument 1, and the options. Goes to all or something.
Yeah, that worked. Michael, does that satisfy what you were saying?
Not quite. I would like to supply the option later, depending on the function.
Well, then you have to treat it as an argument. You can say carry plot, 3, and then
this curry is not working with varargs things.
Okay.
If that's what they're asking.
Okay.
So in other words, that was another case we discussed, was the case of plus, for example, of making a curried form of plus where you can just keep going and adding arguments, but we don't see a way to do that. All right, so let's loop back. So what were the further questions that you had, Jose? And then let's look at a few other things, and then we'll come back to this.
Yes. So the thing
I do want to come back to the name because I don't like the name. Okay, go ahead.
Yes. So in the ref page, there is a new comment there which I'm calling 2C. So I was exploring the possibility that we discussed yesterday of having list goes to list or permutation goes to permutation.
Right.
To allow the possibility of permuting the arguments of the carried function or permuting the arguments of f itself.
Right.
So there is this mapping of the arguments of carry f to the arguments of f, and we can permute both.
Okay, so what we're saying is, in here we've got something there, and we've got the argument sequence here, A, B, C, for example, and there's the question of whether, in which order these things are picked up, and in what order they are filled into the arguments of f. Correct?
Exactly.
And in a more general case, we have it's somewhat more complicated because we have things like this, and we have to say whether you pick up, you know, each thing has an address here which you can in principle pick up.
That's even more complicated, yeah.
Okay, but so what did you conclude about the permutation to permutation thing?
Well, the conclusion is that we can have so there are two things here. One is whether the permutation on the left and the permutation on the right belong to or refer to the carried arguments and the f arguments. We can choose any order because this can be read in both ways. But whatever we do should obey this property I've written there, which is when we compose two carries, there must be some identity. You see? So exactly. So we have to make sure that there is this sort of identity. Now I'm not sure whether to read it in the first way I wrote it or in the second way I wrote it.
Yeah, I understand. But do you think it's a good idea to give both permutations, or do you think that it's sufficient to give a destination permutation?
Number goes to permutation is enough. This would add some flexibility in case you want to interpret it as I'm permuting these arguments or permuting the other arguments.
So number as in this case, it will be 4 arrow, and then how you fill in from these things here into the arguments of f. Is that correct?
Exactly. Because, for example, we need this.
In this particular case, what is A? Is A 1, 1 in this case? So I might be saying something like 2, 3, 1, 2. Is that what I'd be saying?
Yes. So I haven't implemented this double list notation, but yes, it could be 4 goes to 1, 1, 2, for example, and then it's going to return f of A, A, B.
Okay, but wait a minute. But that's a different way of doing it, because in other words, is B 2 or 1, 2?
In the current implementation, is 2.
Do we think that's a good idea?
Well, this is something useful also to not have to worry about where I'm putting the brackets.
But notice that there's a varargs play. If you were to say AB, the sequence is 1. For what it's worth. I mean, then that becomes you can move in that sequence of any length, like slot, right? So that's the analog of doing something like this.
Yes, but here we have an additional issue, which is that our semantics is going to try to evaluate head arguments first. And then if that doesn't do anything, it will evaluate with the 2 pairs of brackets. And if that doesn't do anything, it will try to evaluate with 3 pairs of brackets. So because we don't have this pattern that takes an arbitrary number of brackets, the only way of implementing this recursively is by flattening brackets one at a time, which is how this is implemented.
Right. So by the way, relating to this is a discussion that we started, Michael, I don't know, about this nested function pattern business. of being able to write a pattern that will effectively match that nested sequence. Whatever that nested sequence is called, it is very related to this whole currying thing. I mean, you know, it almost might be, except for the fact that I don't think that's a very nice word either, you know, what is the right, I mean, what is this really doing? It is accumulating arguments in some way, this curry thing.
Yep.
It's accumulating arguments by function application. It's kind of like that's a horrible word, but it's like this thing is somehow applicable to arguments, as in the same sense that you might say apply. What did we end up doing with construct? Did we finish that yet?
It's designed, but they're not implemented yet.
We should get that implemented.
Yeah.
Because
is that the one we call of?
Yes.
Okay.
Oh, did we end up calling it of? Or did we end up calling it
No.
construct?
No, construct. But at some point we called it of.
Yeah, yeah.
Somebody is asking whether uncurry would be there as well as curry. Yeah, well, that's another interesting possibility. To take, I mean, how would you take this and turn it into, what do you turn that into? I mean, you could try to turn that into this. I don't think anybody particularly cares about that. That's not an operation that we have found very useful over the last 30 years or something. Anybody see? I mean, the main point of this curry form is because in endless situations in which you are doing, you know, something like that, you want to be able to quickly, I mean, you know, we can clearly make any function we want here, you know, whatever it is. But the question is what we're really talking about is simplified forms of the function that we would write. You know, anything we can do with curry, we can do with pure functions.
Yes.
Am I correct?
Yes.
So it is merely a shorthand for a family of pure functions. So the question is, what, let's see. I mean, the issue that we have here, does anybody remember where I was saving this? Oh, it's under curry.
When we have multiple pair of brackets with curry, imitating that with function could be rather complicated because it would be nested functions.
Which thing?
I mean, having curry imitating one pure function is easy, but having what we do with curry with multiple arguments imitated by pure functions, it's doable. But I think it would require multiple nested functions.
Oh yeah, it's a mess, which is why we have a function to do it.
Exactly.
Right.
Yeah.
But the question is, you know, in some sense, what are we doing? What is the thing that we are achieving with curry? We are making this thing F somehow, it's not the right term. I mean, applicable is not the right term. What is that object there? What would you call, what would you put, what name would you give to this to mean that this is going to construct, you know, is going to be waiting for, I mean, this thing, like we have function, right? Function is something that waits for something to be fed to it, right?
Mm-hmm.
So that's a good example of something which waits for, you know, something to be fed. So this is another thing that in a sense, in its partial form here, you know, this thing here is waiting for stuff to be fed to it.
Yes, but I think the key point here is the bracketing. It's something like converting a single pair of brackets into a multiple pair of brackets. And that operation, I don't know, it's some sort of partitioning of the arguments.
It makes me think of compose. So maybe compose with or something like that.
No.
It's a flattening and a compose.
I don't think this is composing.
What are you saying? No, it's not composing, but it is. All right. Anyway, what other questions were there that are so? There's this question about what to do with variable argument sequences.
Mm-hmm.
What other questions are there that are still outstanding?
Well, to me, the main fundamental question from the point of view of implementation and this and syntax is the notation of list to list. Do we admit list to list, or are we happy with number to list only? It is enough.
Where the right-hand side here says how to take the sequence of 1, 2, 3, 4 arguments in these brackets
mm-hmm.
and stick them into the arguments of the function.
Exactly. Yeah, so 4 means wait until you have 4, no matter in which bracketing form they are. And then there is a list of numbers which are basically like the slots of function, and they can be repeated. So it could be 4 goes to 1, 1, 3.
Yeah. What on earth can we call this? I mean, it's something about application, function application, isn't it?
Yes. But
okay, here's a really weird one. Partial construct. I mean, it's a very long word, which is kind of painful. But the idea is if construct makes this, so what does construct of f of x, what does this do, f of x, y?
Yeah, our idea was that that would be returning f of xy.
F of x, y, as opposed to f of x of y. As opposed to returning this.
Yeah.
Which one? That it would return
the first one.
This form here?
Mm-hmm. Yeah.
I see. So in other words, it's effectively turning a sequence of arguments into a head and arguments. And so how do you make this one? How do you make this?
That would be a folding construct. That would be fold.
Okay, so what you're saying, so if we say fold of #1 of #2, right? Which
you can just compose right now.
How?
Just compose. Compose, yes. And now that would be the list f
of x, y, z. Okay. Okay.
So having the construct would do the same thing.
Okay, so this is, in a sense, a this is in a sense a decompose. I mean, this is a fold of. This here is a compose.
Mm-hmm.
Is that how compose? That is the official way it works, right?
No, compose is composition. That's a different thing. It nests.
Wait a minute. Is compose what we deprecated in favor of composition?
Yes. So right now the syntax would be.
So this becomes construct.
Yes. To recover that, we would need construct of composition of f x y comma c to get exactly what you just got.
Okay, but then that would be. I don't understand here. So you're saying, no, that should work with look, construct is effectively #1 of #2, right?
Yes, for two things. Yeah.
So right. So this will do that.
Yes.
Right?
Yes, but I'm saying that that's not the current compose.
I understand. Somebody is talking about the arrow interface from Haskell. I don't think we have any Haskell users on this call. It could, does anybody know how that works?
I don't.
I mean, the analogy, the analog of that is using #1 and #2, which allows you to pipe arguments any way you want. In other words, you can use composition. You know, we can perfectly well write functions with all kinds of funky composition rules, but we have to name #1 and #2. I mean, if we wanted to, we could be using combinators, but I think we're still going to have to number. You know, we can make sort of a combinator thing that will, you know, so it's an interesting point. If we say, how do you feed in arguments? How do you feed in a third argument? Well, it's not really a great, now I'm curious what this Haskell arrow notation is because I don't know. Let's see. Arrow tutorial from Haskell Wiki. Let's see, what does that do? Arrow builds an arrow out of a function. Okay. Interesting. A simple arrow. Yeah, well, right. That is similar to our function, I think.
Exactly, that's our function.
Yeah, I think so.
And we do have an arrow notation for our function.
Indeed, we do. Right. So we just have to, so in other words, this is like x function, x squared, and so on,
yeah,
which is otherwise that.
Mm-hmm.
But now what is this? And how does that relate to, I mean, that's another interesting possibility, that there's a special character form of this. I think we don't understand this as well as we should.
Well, that function we can put in the first argument of carry. So we can
What
have
function?
The arrow that you just wrote. We can have.
No, sure. I mean, we can certainly say curry of that.
Mm-hmm.
I mean, actually, we can say curry of xy goes to, you know, y comma x squared or something.
Yeah.
And then we can say that becomes something that we can then say of AB, for example,
yeah,
and that will become like that.
Mm-hmm.
It is kind of funky that this is by default reversing the argument order. That does bother me somewhat. And it kind of suggests that.
But in most cases in which we want to just use carry of something without saying comma something, it's what we will need. So you can just say comma 2.
Yeah, we don't want to have to put a second argument there. The only point is that the name curry may not be the right name, given that it does by default, that the default case is to do this slightly weird thing where it is making itself ready to take a first argument, so to speak.
Mm-hmm.
So in other words, if I say curry of f of y, it's making itself ready to take the x argument, right?
Yes.
So the question is, how can you say that?
Would it be weird to call it functionalize? Like we're kind of, again, transforming it into a pure function to some degree.
Well, are we?
Well,
I mean, that's along the lines of these operator things. What's that?
Yeah.
Go ahead.
I was going to say, yeah, I mean, the thread we seem to come back to is that the output of curry is most similar to a pure function, or at least the function head we have. That's the closest analog we have in most cases.
I agree.
So maybe along that line.
I mean, it's a little weird. If you see that in a piece of code, you're never going to figure out what it does.
Yeah.
So in other words, if you see functionalize of f of y, you're never going to figure that out.
Yeah.
I mean, frankly, you're never going to figure it out if it says curry either.
Well, but
what is a word? Yeah, go ahead.
We have set delayed, which does the setting at a delayed time in some sense. What about function delayed or a flavor of it? Because in some sense, we delay a certain operation.
Yes. Well, I mean, alternatively, it could be something like argument. Yeah, I hate this. This isn't quite right. It's more like argument delayed.
It's more argument supply delayed.
Yeah, by that time, we're writing a whole essay.
Yeah.
I mean, or apply delayed. Nah, horrifying. I mean, apply something or other could be usable. Okay.
Perhaps it's because I'm already used to it, but I still like curry because we call this currying. And it's such a short thing. It is very nice.
Well, I agree. Okay, difficult problem. All right. Okay, so we've still got a naming question here, but let's keep going with the rest of our discussion. Okay, can we move back to I mean, we were talking before about this possibility of a pattern construct. Michael, do you have any comments on this? So you understand this pattern construct would take.
Yes. And it would work that I can make it anywhere in the head. Like there are 20 nested heads, and anywhere I have capital X.
Well, so what I'm saying is this would say nested. Let's see. This would say, let's say nested. What would be the right term for it? This would be like repeated, but it isn't repeated. It's nested, right?
Yep.
The analog of repeated. So in the case of repeated, what we're saying is f of repeated of x, you know, goes to, you know, y or whatever it is, right? And what that matches is f of x, 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 x. And if I were to say, yeah, repeated x blank repeated, then I would get that. Okay, so what's the analog? So nested here would be.
But we want something more general. We don't want the same.
No, I understand. But here you can have it not be the same, because if you say f of repeated. Oh, I see what you're saying.
It would be repeated blank or blank blank.
Repeated blank without a name.
Right.
Right. Yeah, that will match any of those patterns. Mm-hmm. So here, I mean, look, really what this is the analog of it is a blank nest, so to speak, in the same sense that blank sequence, that x blank blank is blank sequence, right? So if we have f of x blank blank representing f of any sequence of arguments, that is blank sequence. What we want here, so that is equivalent, that is the same thing as f of x colon blank sequence, right? So then the question is, what can we do that would represent, so what would be the corresponding thing for a blank nest?
But I'm not sure this is nesting. If we do nest f comma x comma 5, we don't get multiple brackets.
I see what you're saying. So we could equally well say here, you're right, it's not. It's a multi-composition.
Right, sub-value.
I mean, it's actually.
We probably need the word that we are missing in previously, the curry word, the equivalent of curry.
I know. That's why I'm bringing this up.
Yeah.
Mm-hmm. I mean, because what we would call it is a sub-value. Right. That's what we would call the value version of this. I mean, the words we have are apply, construct, sub-value. Right, but what this is a we're hearing some breathing here. Okay, so that thing there, what are we calling this in the world of trees? Because the tree form right now, the tree form of this is something rather silly looking, right?
Mm-hmm.
Not even breaking it up. Humph. Okay, listen, let's try and loosen ourselves up here with some hopefully simpler discussions. Let's
Yes.
talk about the.
This is something that Xavier has found, and it's that the implementation here is a bit more general than what we document. So we are asking for permission to
What on earth is all this?
Yeah.
The number of Turing machines with this number of colors is documented to be this. Well, is it just wrong?
Turing machine is able to handle more rules than the documented.
Well, so for example, in the
table.
case s equals 2, k equals 2, I know the answer is 4096. So let's see what that is. So that's 4 to the 4 would be that. Okay, so you say it's 4 times 4 to the 4. Oh, that's really weird. How can there be? I don't understand. So what's going on
Well,
here?
it's a two-dimensional one.
Oh, this
has
is
more.
Two-dimensional.
Yeah.
Okay. Okay. So what's the issue? So is this just an error?
The implementation can handle the equivalent of 8 there instead of 4.
No, I understand that. But so the table said 4,
exactly.
but it seems like that's just a bug, right?
Yeah. Yes. We just wanted to check that you agree with.
I have no opinion about that. I mean, I have to work it out. If it's a bug, it's a bug.
Yeah.
I mean, do we need to? It seems like it's just a bug. I would fix it.
Okay.
Okay. All right. Let's move on. De Bruijn sequence review. Okay.
Yeah.
This is fairly trivial, right?
There is an issue that we have been discussing, which is the standard seems to be to use 0 to n-1, while probably in the Wolfram language, it's better to use 1 to n. So we wanted to know your opinion.
Okay, well, so wait a second. So you're saying, is it in one of these? Is it in the X kernel?
No, we don't have it yet in the X kernel.
Okay, so I have to look at this. Okay. Okay, let's look at the example first.
Yep.
De Bruijn sequence of 0, 1, comma 2. What is it giving here? It's giving a sequence where you're always sliding down. Given the symbol 0 and 1, you're making a sequence which has the property that a length 2 block.
Yeah.
That you never repeat the length 2 block. What's that?
I mean, that all possible lengths to blocks like 0, 0, 1, 1, and 0, 1 are always there consecutively.
Yes. Right. So in this particular case, if I take that De Bruijn sequence and okay, and what I do there is I say, so there's an identity that you should probably have here, right? The partition of that, comma 3, comma 1 should be the 8 sequences like that, right? Why are there 7? 6? I'm confused. No, it's not all possible sequences. It's the no.
It's
go ahead.
2,
what is
1.
it?
It's 2, 1.
But that came out from comma 3 here. So you're saying comma 2, comma 1. No,
yes.
that gives the repeats there.
But here it's separated, let's say. So you have 0, 0 and 0, 1. So you slide on the list by block of 2.
So wait a minute. So that would be partition comma 2 there. Right, that's correct then. So I don't understand this case then.
Are you sure, Xavier? No, I think this is sequences of order 3. but perhaps there is cyclic. It's a cyclic condition.
No, so this will
I
be
see. That
exactly.
makes more sense.
Yeah, so it's 3,
Right.
comma
So
1,
it's 3, 1.
and yes.
But then what's going to happen here? Then you're going to get.
It's 3, comma 1, comma brace 1, comma 1 brace to have the periodicity.
Like this?
Yeah.
Yeah.
Okay, I'm officially a little bit confused. So this is generating all possible. You should, by the way, give that example here. Yeah, this is generating all possible sequences, all 8 sequences, so but in some slightly funky order. What's that?
So if you take the output 2, you take the first 3, this is 0, 0, 0, so this is the first element of partition. Then you slide by 1, so the second block is 0, 0, 1, and this is the second element of partition. So yeah, so that's it. And then you slide again, it's 0, 1, 0, and this is the third.
No, okay, I understand. Yeah. So this seems fairly straightforward. This case seems, well, yes, this case seems fairly, okay, so what's the question here? So this is saying,
yeah, so the question is that if the input is the Brownian sequence 2, 2, do we interpret that first 2 as 0, 1 or as 1, 2?
I understand.
I think it should be 1, 2.
Well, I don't think we necessarily should support that there. I mean, it's the same issue that we have with tuples, right? I mean, this is the same kind of deal. You know, with tuples, you can give whatever you want there. Right? So, I mean, this is similar. I just wouldn't support this case. If we do support this case, and I'm skeptical, it should work like digits and should have zeros here, in my opinion.
Well, we have the Brownian graph already, and it does support that case. So I think we should imitate that.
Okay. So if I put in labels here, that's not very helpful. Let's see. Let me do a 2, what would be the right thing? 2, 2, 2? That's a very ugly De Bruijn graph. So what I really want the vertex labels is to apply a function, is to apply integer digits, 2 to that, right? This is a very messed up De Bruijn graph. I mean, usually you draw a De Bruijn graph. I mean, it has a certain symmetry, which is not, well, it is being captured in this picture, but it's being captured in a rather weird way.
But I think our sequences are paths in this graph. So probably what this means is that it does use 1, 2, 3, 4.
Yeah, which means that I don't understand how that would work. That means that those things are not, the integer digitified version of those isn't going to be correct. Do you see what I'm saying?
Oh, I see what you mean. Yeah.
What is there a vertex labeling function? There is, isn't there?
There's a named vertex.
What function? We don't have a vertex label function.
Okay, well, how do I get the integer digits thing of those? Can I just put a function in here?
I don't know.
Yeah, so this will be a rule. So you
not very helpful.
Yeah, so you will need hash goes to integer digit of hash, and you map this expression on 1, 2, 3, 4 on range.
I see that. That will certainly work. Okay. Oops. Oh.
Oh yeah, there is an issue with the list. It's superimposed.
What's that?
Actually, I think all the digits are superimposed. You can see on the top now.
Yeah, it's not very helpful. Oh, whatever. Okay. so fine. I mean, we can probably get that will probably work. Yeah, there we go. Okay, and we didn't tell it the leading digits there, although I don't know how many, so it's comma 2 there. Okay, so those are the digits of those numbers, right?
Mm-hmm.
You know, this is consistent, right? To generate the sequence with 0 through whatever is consistent with what's happening here, isn't it? Because this here is the labeling of nodes, whereas this here is the contents of those nodes, if I'm not mistaken.
I see.
Right? It's the same thing that you'd be doing if you say, I mean, if I say range of whatever, and then I would say integer digits to get, yeah, I think it's consistent.
Okay.
So I would say that the correct thing to do is to have it go, is to be something where if you wanted to get the numbers of, you would say from digits comma 3 of those, of the sliding window on that list, right?
Mm-hmm. Okay.
Okay, so I think that's consistent. And here, yeah, that's fine. Okay. What else do we need to figure out with the Brine sequences?
I was a bit concerned with the use of the word alphabet here, rather than list of elements or something like list of.
Yes, we should not say alphabet. Returns a De Bruyne sequence of the elements in, right? That's what it is. It's of the elements in list.
Yep.
Elements in list. And it's basically taken k at a time, isn't it? Taken n at a time.
Yep.
If I'm not mistaken.
Yes.
Yep.
Okay. And I think that would be better if you're really going to have k there. I guess you can do that. Okay.
We can say on the list.
That's the De Bruyne thing. What's that?
We can say on the in the second line on the list 0 to k to n to k minus 1.
Yes, returns it to it. Well, why don't we take for the Brine sequence of the elements 0 through k minus 1.
Mm-hmm.
Returns a De Bruyne sequence of the characters in string. Actually, maybe we should say based on, you know, of the elements. It's okay.
Mm-hmm.
It's okay.
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 Mm-hmm.
The shift register sequence, fairy sequence is not spelled correctly and will clearly not work there. Right?
Mm-hmm.
What is the relationship between the fairy sequence and the De Bruyne sequence?
It was mainly to add a sequence, another generation of sequence of number in the C also section.
But do you know whether the fairy sequence is related?
I don't think there are. No.
I'm pretty sure it's not.
Then I don't. Is it really relevant to talk about fairy sequence? Because shift register sequence is related to the De Bruyne
Yes,
sequence, right?
they are related. Yes, yes.
In fact, they're very closely related, and I would even put shift register sequence before tuples because I think it's really closely related, and I would drop fairy sequence because I don't think it's very. I don't know of a relation. What about rotate left? Is that related? Or partition for that matter?
Partition, yes.
Okay. All right, let's keep going here.
Mm-hmm. So there was a suggestion of reverse sort by. So we have added recently reverse sort, and because people typically understand better the use of the f function in sort by rather than the ordering function in sort, we have got a couple of suggestions that we had reversed SortBy.
You know, if we only could solve our currying problem, then these functions all become, well, maybe not. I mean, yeah, it all becomes a little bit more straightforward, because this becomes, I see what you're saying. Yeah, okay, that doesn't solve that problem. I guess I'm okay with this. I mean, you know, look, sort and SortBy are two things that are kind of on an equal level in terms of utility. What is this? SortBy.
Yeah, so we have discussed this idea. So the main point here is that we have a function that takes an f function and another function that takes an ordering function, but we don't have a function that takes both. So the idea we discussed is to have SortBy taking both with this notation, f arrow p. That's going to be very powerful, so we're working on that. Now, I'm a bit concerned with the fact that this seems to be like an option. So that notation of having a rule at the very end could be problematic if we add options or if the function interprets. So I was wondering whether there's an alternative notation. Now, SortBy already takes a list.
Well, what does it exactly mean? Why is it a one-way rule?
Well, it means first take the f of the elements in list and then sort them with the ordering function p.
And how many arguments? Yeah, why not use a three-argument form? So why not have f and then the SortBy? So in other words, sort only has two arguments as well, right?
Yeah.
And it has an ordering function in it. So it's like the ordering, and then there's the ranking function, effectively. I mean, that's a possibility.
Yes.
So this one would have the ranking function and then the ordering function.
Yes. So perhaps we can survive with one of them only. I mean, adding it in both so that they become equivalent is a bit strange.
Not that strange. I mean, if we're going to do it, then, you know, sort defaults to an ordering, SortBy defaults to a ranking.
I see. Okay, yeah.
Because ultimately what's going to happen is, and there's also a question of what the priority order is of using ranking versus using ordering.
Yeah.
Right? So presumably in SortBy, you use ranking first, and only to break ties in ranking do you use ordering. Am I right?
Well, it's not so much breaking ties but for example, if you have, the example I gave recently was, we have a list of vectors and you want to rank them by norm, but of course, norms are numbers, so you need to use numerical order in the third argument, because otherwise we will get two
wait a
square
minute. That's a different thing. That's a different thing. So that's saying that's a composed ordering and ranking. That's different from this.
No, it's this. So I mean, the breaking of ties would be if we have a list in the second argument and in the third argument, so that the first function applies first, and then if there is a tie, we use the second one.
Oh, so you're saying, does that already work? So I mean, if I
yes,
say
in SortBy.
But what about that case? Does that use F1 function as the first ordering function?
No, this will be some sort of tensor product or Cartesian product of orderings. We don't support that yet. But in SortBy, we do support a list of F functions.
Okay. Oh yeah, breaks ties. So we probably should have a similar thing for breaking ties with ordering and sort, shouldn't we?
We could.
I mean, that would be the symmetric thing to do. Okay, so this has nothing to do with breaking ties. So this has to do with, but I don't understand why. So is it obvious that the sorter for the rankings is itself an ordering as opposed to another ranking? Why isn't it SortBy, so to speak?
Yes. So the ordering function is a lot more powerful because it takes two arguments. So it knows more than the ranking function, which takes only one argument. So basically, the ranking function is just being applied to the to the list. It's being
well,
mapped.
One point about the ranking function is the ranking function better return a real number of some kind. Isn't that correct?
No, not necessarily. It could return, say, a string, because it's part of.
I see, but then there's a question of what is the canonical ordering applied to the ranking. Okay, so in other words, SortBy takes the list, applies the ranking function to every element, and then has to sort. See, but you could imagine, look, you could imagine something like this. You could imagine a SortBy of a list of random complex numbers, okay? So let's say I say random real, okay, so this is going to give me whatever that, I should have given the SortBy argument here. So let's imagine that I give that by, well, abs is a bad example. What could I do? Well, I could say this thing here, anyway, the ranking function is going to return real numbers, complex numbers.
Yeah.
But then onto that ranking function, and there is a canonical ordering of complex numbers, which would lead to some ordering. But then what I want to do is overlay an abs ordering on those complex numbers. Am I making sense?
Yes, that's yet a different thing. So the ordering function is a way of specifying any general order. It could be even a partial order, because mapping things into reals means a total order. And it's not always the case that we want that. So, so the need of ordering functions is always there for some cases that cannot be mapped into reals.
Yeah, I understand, but aren't we saying the same thing? I mean, so we're saying in SortBy, the ranking function takes the elements in the list and applies the ranking function to them and generates something which is more canonically orderable than the original elements in the list.
It's something orderable, not necessarily more.
Okay, fair enough. Well, I mean, but look, the elements in the list are always orderable too.
Yes,
it's
but
just you don't like the canonical ordering.
Exactly, you want another order.
Right, so what we're saying here is the same thing is going to happen the next time around. The ranking function is applied to the list, and it generates a new list, right? I mean, all that's happening is internally, right? If we say sort by list, comma, f, that's equivalent to applying f to list and saying sort f of list.
Well, you are going to return the original elements of the list.
I understand you're going to return the original elements, but that's the sorting operation that you do is that sorting operation.
Exactly.
Correct?
Exactly. But you see, the second sort has a p in the second argument.
No, I understand. So what you're saying is that this is the ordering criterion here, but you could as well, instead of doing that, you could, in the second thing, you could do a sort by f/at, and then the generic, then the identity function here. Right? That will be equivalent, if I'm not mistaken, to what's happening now with SortBy.
Yes, but there are some some orders which are partial orders, like the form lattice, things like that, which are not implementable via SortBy.
I understand. I understand that. All I'm saying is that for convenience, you're saying SortBy applies a function to determine the ranking, then those rankings have to themselves be sorted somehow.
Exactly.
Right?
Exactly. Could be alphabetically, for example.
So now we're saying, and what you're saying is that the most general way to sort the rankings is with an ordering function. It's with a 2-argument ordering function. Okay? And what I'm saying is, yes, that was why the original sort function had a 2-argument ordering function, but we found that sort by is often more useful to have a 1-argument ranking function. So I'm asking the question, why do you think that the 2-argument ordering function is the thing to give a privileged position to in the thing that happens in the ordering of, in the sorting of rankings, so to speak?
It's just generality. It's just that it's the most general case. I mean, I can easily implement an order function from an f, while it's very difficult to, in general, not possible to implement an f that gives.
Well, so what you're saying is, so let me argue this another way. Okay, so what you're saying is that this is the fallback position. So what's happening is that this F is just a sort of a cheap way. You know, in principle, you can do everything just with this case, right?
Yes, yes. But we would have to compose the P and some sort of order that comes from F in a complicated way. But yes, it's the general case.
Right. But so what you're doing here is the presence of an F is a convenience, but you're saying you can fall through to what you can do with generality with the P here.
Yes, I'm saying that right now we don't have an easy way to do the very simple thing that you have there with the F and P.
Well, I understand, but why is it simple? I mean, so in practice, what would this actually be? This would be some kind of lexicographic order and things like that?
Yeah, we could have some sort of F function that extracts strings, and then we want to sort them in Russian. So we would write F, comma, alphabetic order of Russian.
So you're saying, so the typical cases that you are imagining are does that work to just say Russian? I think it's curryable like that, right?
Yeah, it is. Yeah. That's a typical case, or numerical order, because we get exact numbers and we want to sort by numerical order.
This seems fairly sensible to me. I buy this. Anybody object to this? No? Let's do it. I don't believe in this. I don't think we should do this. I think it should just be a third argument.
Okay, sounds good to me. And you still want to sort with 3 or just sort by?
I don't think we should bother with the sort with 3. You've given an argument why that's unnecessary. Just sort by, right? Because sort by is the less general function than sort. Right. So I mean, if you look here, okay. So this, in the order defined by applying F to them. So then the third case would be sort by. So we've called it P in the other case, right?
Right.
Uses, what do we call it in the case of sort? The ordering function. Uses the ordering function P to order the results from applying F to each element of list. Is that right?
Yeah, exactly.
Okay. All right, let's leave that for right now, futurized, but I think that makes sense. Futurize that. Okay. All right.
Great.
Okay. Let's go to your last thing here with the sequence replace issue. What is this?
Yes.
Use of sequences versus lists from the second argument of sequence replace.
Okay. Yes. So this is a new function we have to replace sequences, and we are using the notation list goes to sequence. So you see there 1,2 is replaced by A.
Yes.
So the point is that yeah. So we are not.
It's a list which is standing in for a sequence.
Exactly, like we have done for sequence cases, sequence position, sequence
But
count.
wouldn't this work? By the way, does this work in the X kernel?
Xavier, do you remember? No, I don't think we have placed this yet.
No, not yet.
Okay, but I mean, this case here, if what you did instead of that was
replace or replace all.
Well, no, if you did this, wouldn't that work? No, it wouldn't work.
Here, this will work. Yes, yes, this will work.
What does pattern sequence? But pattern sequence will just represent. Yeah, that's fine. So that will be. So in the more general case, you could do something like pattern sequence of x blank, which would mean any subsequence of repeated elements, right?
That's right. Yeah.
Yep.
So what's the problem with this? The naked sequence doesn't work? Who cares?
What happens if you had string replace and the first argument had a head that was not list, say F?
String replace? What's string replace?
I'm sorry, sequence
You mean-
replace. Sequence replace.
Okay,
So
I see. And this thing here, go ahead. So does it work with non-list heads? It should do. I mean, the heads should match.
So you would want F of pattern sequence of XX.
Well, the question is, does this work?
That's a good question.
I don't think it does. So right now, we are always requesting lists in both cases, like we do in
But
sequence
I mean, in
cases.
principle, we could do matched heads, right? If F was effectively, you know, that is effectively a flat F of in some sense. This is pretending F is flat, and the other one is pretending list is flat.
I see. And yeah, so the question would be in this language whether we also need an F head on the right-hand side of the rule.
That's the one identity question. Right, so in other words, does that, and if you have an F head on the right-hand side, does it strip it? Because it's not going to strip a list on the right-hand side, is it?
Right now, we don't.
No, I don't think we should. I mean, if you want it
I don't
stripped,
think so.
okay, so your issue, the issue is if you wanted to splice it in, okay, so here's the bad case, right? So let's say I do sequence replace of 1, 2, 3, 4, and then I say 2, 3 goes to 1, 1, 1.
Right.
Okay. Okay, that's going to insert 1, 1, 1 in the list, which is really kind of ugly because it's not what you want most of the time. You really actually want to splice 1, 1, 1 into the list.
Yes, but that
this can be easily fixed.
Yes, but it's a different interpretation, right? Because now if we want to replace 2, 3 by 4, we would have to say list 4.
Right.
I mean, if I wanted a sequence, I would use rule delayed and sequence.
Ugh, I hate sequence. I mean, it just blows up everywhere. You know, that's what the fact you have to use rule delayed is fairly horrifying. Why are you using rule delayed in all these places, Xavier?
Yeah, it's not necessary. Yeah. Just a rule is.
Well, it is necessary as soon as you do that case, which is a horrific case.
No, it would work also with rule. It would be necessary if A was in the left-hand side. So rule is also sequence hold.
Oh, rule is sequence hold, so I can say 1, 2 goes to sequence. So I can do a splicing like that.
Yeah, exactly. Yeah.
It's kind of grotesque, though. I hate encouraging people to use sequence. I mean, the whole point of having these functions like sequence replace is to make it unnecessary to use a naked sequence.
Yeah, indeed. So the main issue is that right now we are using lists to represent sequences on the left-hand sides, but not in the right-hand sides. And we wonder whether it should be on both sides.
Sorry, say that again.
Yes, that the issue discussed here is that right now we are using lists to represent sequences on the left-hand sides, but not in the right-hand sides. And we wonder whether we should do it in both.
Right. So there's a question of whether it auto splices from the right-hand side.
Right.
which would force you, if you wanted to have a single element, it would force you to say 1, 2 goes to list A, for example.
Yes.
Right.
Exactly. So if the user writes something on the right-hand side which is not a list, we would say no.
Well, as a courtesy, we might splice it in.
I see.
Okay. I mean, what are some analogous functions? I mean, we have sequence align, don't we? Which is a sequence alignment, which has some similar issues, I think. So what does that do?
Perhaps sequence cases would be closer.
Fair enough. So what does it do? When it has... So that's an example where it is not auto-splicing here, right?
Yes, because this is extracting. It's not... I mean, the fact that it returns a list is not the same list as the original. It's the list of cases. So it's a bit different.
I see what you're saying. Yeah, I see what you're saying. Right. Well, what are some other replace functions? Do they do... What does string replace do for itself? I mean, string replace auto-splices, but it doesn't have any choice because it's just characters, right? Because string is effectively a flat function.
Yeah.
What does that do?
It's the permutation version, which is basically taking objects and replacing using a permutation interpretation.
Right. Okay. Well, I mean, look, my tendency is to say that this should splice, that you should be required to do this. I mean, the role of this function is it is replacing sequences.
Mm-hmm. Yeah. Xavier, what do you think?
Yeah, I agree to have the list on the right-hand side as well.
Mm-hmm.
Okay. Yeah. Well, I mean, it's not obvious the syntax is right because I mean, another like, could whoever could put themselves on.
That's me. Sorry, I'll mute.
Okay, I mean, in a sense, a more natural thing might be, but then we're into some totally weird. Then why are we even doing this? I mean, then. I mean, this is certainly related to things like combinators, right? So, I mean, a combinator, I don't even know, you know, I mean, the typical combinator, right? The K combinator K of, let's see, how does it work? Of combinator K of X of Y is the same thing as X, right? If I'm not mistaken. And then combinator, so the point of a combinator, typically in the way that combinators work, they are sort of auto-currying. I mean, they're always curried. They only live in a currying way of doing things. I think that one is, what is it? It's X of Z of Y of Z, right? So those are typical, go ahead.
There is a Wikipedia page for currying using precisely that word. So I wonder whether we can learn some terminology there.
For what? For currying?
Yeah.
Let's see what it says. For the cooking process of the same name, see curry. Great. Evaluation of function takes multiple arguments into evaluating a sequence of functions. Yeah, well, that's the other way around, right? This would mean that what we're doing is uncurrying, right? That takes multiple arguments, right? That would be saying that the curried form of, that would be something which would say something like this, that goes to f of x of z, right?
Well, we can read it in both ways, because curry of f can be read as transforming the function f that takes several arguments into a function curry of f that takes brackets.
I see what you're saying. That makes some sense. Right, so the curry of f is a multi-arg.
Right.
Okay, so f is a var-args function, let's say, is a multi-argument function.
Mm-hmm.
Curry of f is a nestedly applicable function.
Right.
Well, so let's try that again. I mean, so
You could say multiply applicable.
What's that?
Perhaps the word here is multi. Multi-arguments versus multi-applicable.
I see. So that's multi-argument. So it converts from a multi-argument to a multi-applicable function.
Right.
Well, that's a reasonable concept for what it does. Okay, I like that. But now the question is, what should it be called? We can be incredibly obscure here. Let's see, what is it talking about here? So, yeah, I mean, these are the standard kinds of coboardisms and things. These are the standard. Really, it was introduced by Frege. I mostly knew about its use by Schoenfinkel. Defunctionalization. What on earth is that? I see. So if that was what that was called, then functionalize would be the corresponding name here. Wouldn't it? I don't know whether it would be. But you're right, that this is a wrapper for the head.
Yep.
Partition, if I could spell. Right, so I mean, it does kind of suggest with this, what on earth would, if you read this thing, how would you know what it meant? How do you read this and have, because, no, this is, okay, so the other possibility is curried of f, but it's not really helping anything.
Yeah, I do prefer
curry of f.
Yeah, to me this is closer to transpose, for example. It's the action of doing something.
Okay. Now the next issue is why curry of f flips its arguments in that weird way.
Yeah.
Right? Even though it's the more useful form.
Mm-hmm.
It's hard to justify that because it's the naked name is just going to be
What about forcing people to write something in the second argument like a two-way rule, which is nice to say flip 1 and 2.
Well, so what you're saying is curry partition. Oh, I don't know.
But forcing
That's
seems
getting
very
into
strong. That seems very strong.
Which?
Forcing a trivial statement seems very strong.
Well, I agree. But the difficulty is that this form seems wrong. I mean, in other words, the fact that this will wind up in the wrong order seems wrong.
Well, we have
but we can still do this and kind of you force only to use the 2-argument form if you want to switch.
No, I understand that, but this default case seems wrong.
We have transpose.
What's that?
Transpose does precisely this case by default.
I understand, but transpose, everybody thinks transpose interchanges something, whereas with curry.
But the just pure curry can do, in quotes, the right thing, the x, y, and if you wanted to switch, then you have to give a second argument.
Well, I know, but the default case, we believe, is I mean, so if you give this.
But this has been based on the function that we often curry. This has not been proved on 200 randomly selected functions.
Why don't we introduce 2? So like we do with log2, and we have a carry something which does this super frequent case, and then carry is strict.
That's possible.
Yeah, carry 2 or reverse carry.
Curry reverse.
Carry reverse.
Reverse curry sounds like it's going to be uncurry.
I see, yeah.
But we don't have an uncurry form, right? Because what we have to go from, so in your version of this, see, in your version of this, currying this, to many people, currying that would give this.
Not really. We should carry the function, because the function may evaluate. So we cannot trust that the function is going to do something.
No, fair enough, fair enough. Okay, so fine. Okay, but so the proposal, so this case here does not interchange things, which might be considered unfortunate or might not be considered unfortunate. So in other words, in order to interchange things, you would explicitly have to say curry of F to 1.
Right.
Right?
Mm-hmm. We could admit like curry F comma reverse. It's interpreted like that or something like that.
Ugh.
I'm just trying to be.
Yeah. But I mean, I still think curry reversed.
Mm-hmm.
Curry lost. I don't know whether it is lost. It's just second, right?
Well, we could also say last for functions that take more arguments. For example, transpose by default transposes the first 2 levels, even if the array is very deep.
Well, okay, so curry last is a possible thing to mean, if we say curry last, that's not going to work. Look, we could say curry last of f, x, y, z.
Yeah, and then
I don't think that's going to, what would it do?
Yeah. Yes, it cannot
It won't
know.
work.
Yeah, you're right. Because it needs to know how many arguments there are before knowing what is the last. Well, perhaps we need carry 2, and it means carry the second one. It's carry second.
Yeah.
Are there really so many convincing examples of this?
Well, nearly, I know, 90% of all the functions we have carried is for the second one.
But then we ended this. I feel like this exactly is the subset. It's a little bit circular. It's the subset that is curable with respect to the second.
Not really. I mean, there are functions like part, for example. We never were able to have a carried version of part, right? And if we did, we would carry the second.
But integrate, I think you would always curry with respect to the first.
Why? I mean, look, in the case of part, okay, so that would be curry part for you know, and then that's an operator to be applied to 1, 2, 3, you know, 5, 6 or whatever. I just wish this word was more readable. I mean, this is just so obscure.
The input or the output?
The input. I mean, unless you know.
I mean, part of this is
programming.
Part of this is because if you anyway give the 4 in the beginning, why do you have to apply it as an argument?
What do you mean?
What are you saying?
If basically in the curry of part 4, if basically what you want to prepare is a sink that takes always the first element of something, then I feel like part and 4 come on equal either side, and not the 4 comes one later.
I agree. But I mean,
But
we always know that we
right
can always do hash of 4, right? That will make you exactly what you need.
That's not what I mean. Like, it could well be that the argument that's already given, the 4, is not applied as an argument to the curry, but it is an argument of curry itself.
No, I know. That's what I had a while back, and which just doesn't make a lot of sense. Right? As soon as look, it's like having construct, okay? So construct F, A, B, C, okay? Let's imagine that one of those was missing, but it is the place where you insert something in, right? So you could imagine something like this, where one of those things was, you know, insert here.
Yeah.
I'm making sense?
Yeah.
And that would then become a function. I mean, that's a little bit of a different thing because that's not the multi-step currying business. Because you could imagine something where you have a construct.
So this is a form of slot that doesn't need the function wrapping around?
I suppose. I mean, there is a version of this. This would be a construct block. Okay, so I've got a concept here. I mean, construct. I'm going to say construct function, but it's hard to read. But let's say constructor, let's say. And then one could imagine something like this. This is a little weird, but one could imagine something like this. Actually, what the heck is the point of this? So that is merely equivalent to, I mean, that's just silly. It's equivalent to F of A hash C ampersand. See what I'm saying? I don't think it helps you at all. It's just a way to provide, you know, this becomes a placeholder that shows you where to stick something which is given here. All right, let's see. So we've got a couple of things here. We've got this curry second here, which is potentially useful. We've got the original curry, which is essentially a flattening head. I mean, in the original curry form, if we indeed make curry of F okay, what are some terms that we have? This would be the head, but this is something where it's sort of an auto-flattening head of some kind. It's
Well,
hard
I
to
would
know
call
what
carry
should be
f
solved.
the carried head, the carried function.
Yeah, that's the curried function that applies to x and y and produces the ordinary function. All right, look, my provisional conclusion is that curry with this turning into this and curry second turning into this makes sense.
Mm-hmm. And they would take a number
Now,
of arguments, and for carry seconds, the number of arguments has to be always 2 or more.
I guess so. But I mean, there's a question of whether curry of f comma 2 could default to be curry of f comma 2 comma 1.
I don't like that very much, because if we now say 3, what do we do? Which permutation do we do?
Yeah, I understand. Doesn't make any sense. I agree. It has to default to be the right way around.
Yeah.
Okay. Well, I think this is the best, but I'm still not super happy with the word curry, but we can think about it some more.
Mm-hmm.
But let's go ahead and implement this if we can.
Yeah.
Are we ready to implement here?
Sure, yeah, that will be easy to change.
And let's ask, we can ask Christopher or somebody else what this Haskell arrow thing is, see if we can learn something from it. It may turn out to be just equivalent to our function slot business. Okay. All right. Well, if anybody survived on this live stream, I hope you found this interesting. It's a bit abstract today. Yeah. Well, come back another time for a review of design of something completely different, perhaps. All right. See you all soon.